So continuing on, this question here, we're told fill in the table below to show each number in the form 10 to the power of n, where n is an element of n. And what we know here, if n is an element of n, is that this n, this big capital N, represents natural numbers, which are whole positive counting numbers. Okay, so if I look at this question here, we're told to get this in index form. The first one was done for us already. So 10 to the power of 2. Now you might recognize what they've done here is they've moved the decimal place once, twice to the left. Okay, so in other words, that is 10 multiplied by itself, which is 10. And you do that 2 times. So 1, 2, 10 to the power of 2. So for this one here, I have 1, 2, 3, 4 zeros. So this is 10 to the power of 4. And therefore that is 10 by 10 by 10 by 10. Okay, so that's the next one there. This one here is another rule that you need to know. So when you multiply a base number, so that's your base number, and you have an indice, and you have a base number and an indice, what you do is you add the indices. Okay, so that's 10 to the power of 3 plus 9, which is equal to 10 to the power of 12. Now you could double confirm that on your calculator. Okay, so on your calculator you type in 10, okay, you type in x box 3, okay, you want to get an arrow, multiplied by 10, x box 9, arrow again, and equals. You get 1 multiplied by 10 to the power of 12, and that actually is exactly what we got here, 10 to the power of 12. We want to get this in index form as well, so that becomes 10 to the power of, well, how many 10s do we have? 1. 10 to the power of 1. Okay, that was that question there. It now asks us to write 5,400 in the form a times 10 to the power of n, where 1 is less than or equal to a, but less than 10. So in other words, a is greater or equal to 1, but it has to be less than 10. So it's a single digit number. It could be 2, 3, 4, 5, 6, 7, but it cannot be greater than 10. So it cannot be 10, it cannot be 11, and it cannot be 0 or minus 1, so we're not dealing with negative numbers. It says n anyway here has to be a natural number, so again, that's a whole positive counting number. So we have 5,400. How do we get that to become a number between 0 and 10? Well, what we're going to do here is we're going to move the decimal place 3 spaces to the left. 1, 2, 3. That's 5.4. Now, of course, 5.4 is not the same as 5,400, so what we're going to do here is multiply by 10 to the amount of decimal places we moved. 1, 2, 3. The answer is 5.4 times 10 to the power of 3. Okay, that is another type of question you'd encounter there on indices. Right, so the next thing I'd like to do is I'd like to look here at just other indice rules or some or reciprocal rules that you encounter in second year and that you should know. So say for example I have 3 to the power of, we'll say, 5. What does that mean? It means I have 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. Okay, so this is written here in what we call index form, which means you have a base number and you have an indice. Okay, index form. One of the rules we encountered on the previous page is when you multiply 3, we'll say, to the power of 5, and you multiply that by, we'll say, 3 to the power of 2. Okay, and what you do when you have a base number and an indice and a base number and an indice and you're multiplying them is you add the indices. So add indices. Now you can only do that if the base number is the same. So we can see here we have the base number is 3 in both cases. So therefore I can add my indices. That becomes 3 to the power of 5 plus 2, which is equal to 3 to the power of 7. Okay, that is the first rule for indices. So we'll call that rule 1. Rule 2. Okay, so the second rule here. When you have, for example, 3 to the power of 5, and now we're told to the power of 2, okay? What this really means here is I have 3 to the power of 5 multiplied by 3 to the power of 5, because it's this number to the power of 5 multiplied by itself twice. So therefore, that gives you 3 to the power of 5 multiplied by 2, which is 10. In other words, when you have an indice, bracket indice, that means that you multiply those two indices. So 5 bracket 2 gives you 10. Easy way to identify it is, well, remember, you have a bracket here. Bracket always means indice, or sorry, bracket always means multiply. So 5 multiplied by 2 is 10. Okay, so that's the next rule you need to know. So what if I encountered an awkward number, like for example, minus 5 to the power of 3, and I want to work that one out? Well, you could opt to use your calculator for that one. Okay, so we could say bracket, and we could say minus 5 bracket. You put in the X box number, which is 3, and you click equal to. You end up with minus 125. So that's equal to minus 125. How did I end up with a minus? Because I thought, like, when you multiply a minus by a minus, you get a plus. Well, if you work it out, minus 5 to the power 3 means minus 5 multiplied by minus 5 multiplied by minus 5. Minus by minus gives you a plus, and a plus by a minus gives you a minus. 5 by 5 is 25. 25 by 5 is 125. So that's how you end up with a minus 125. Okay, the other type of the other type of rule here when you come up with something in index form could be something we call reciprocals. So, reciprocals. So you've come across this a good bit over the course, which is the square root numbers. Okay, so you could have the square root of, we'll say, 100. And what does this really mean? Whatever number multiplied by itself gives you the number here inside the square root. So for example, 10 multiplied by 10 gives us the square root of 100. So therefore the answer is 10. Okay, you could also end up with values here which are more awkward, and you have to use your calculator. So for example, if I have the square root of 126, for that one, there's no number I can think of multiplied by itself gives me 126. So what I'll do here instead is I'll use my calculator. Square root of 126 equals, I end up with 3 square root of 14. And what I'm going to do with that now is I'm going to press SROD. I get a value there of 11.2249. I'm going to round it to 2 decimal places, 11.22. Okay, so that would be another type of question you might encounter in terms of indices or reciprocals. Okay, so these are all reciprocals, the square root. Okay, hopefully that'll help you out. Best of luck with the questions today.